So what's a complement protein? What possible role could it have in multiple sclerosis? Well, hello, and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam, and I've been living with MS for 39 years. I have been looking over my analytics lately for the different videos that I've been posting, and I'm finding that a lot of what you seem to like are the updates on what's happening in research related to multiple sclerosis. So I've been looking at some of the newsletters that I receive, and I found this article just the other day. I'm going to go through it with you a little bit, and we can talk about what possible use it might have in a future that might not include multiple sclerosis, and wouldn't that be nice? This article just appeared on February 22nd of 2024 in Multiple Sclerosis News Today. It's called Complement Protein Activation is Linked to More Severe MS. And the subtitle is Researchers Explored Whether Network is Activated via Classical Pathway. So right off the bat, what I think you can see here is that this is not going to be something that, tomorrow it's going to be in the pharmaceutical section of your drugstore, nothing like that. This is more fundamental research, trying to understand what's going on at the cellular level with multiple sclerosis. And as the article says, complement proteins, especially when activated in the brain and spinal cord, may contribute to nerve cell damage and more severe multiple sclerosis symptoms, a study that offers insights into a possible therapeutic target suggests. The study, Complement Activation is Associated with Disease Severity in Multiple Sclerosis, was published in Neuroimmunology and Neuroinflammation. The complement system is a network of proteins that work alongside antibodies to surveil the body for worn-out cells and foreign intruders. I think here what you can be envisioning is border patrol, right? That's what they do, is to look for intruders. Says that each complement protein is normally inactive and only becomes activated when some part of it breaks free, called cleaving. Complement proteins have been seen to build up next to antibodies on MS lesions, the areas in the brain and spinal cord that have been damaged by the immune system attacking the myelin sheath, a fatty coating that protects nerve fibers. Here, researchers investigated if complement becomes activated in MS via the classical pathway, one of three activation pathways. Unlike the other two, the classical pathway is activated by antibodies or immunoglobulins of the G and M classes, IgG and IgM. Now, I do appreciate, by the way, there's quite a bit of technical stuff in here, but at least they seem to be stopping to give us a little bit of explanation. So I hope you're not getting too overwhelmed. I don't know how to make this kind of article any more accessible than this writer is already doing. I realize it's technical, but at the same time, I think it's useful for us to know the kind of research that's going on to try and solve the riddle of MS, and that is all to the good, I would say. And they have a section called Results of Complement Protein Activation. The study included 112 people with clinically isolated syndrome, so they haven't been diagnosed with MS yet. They have one symptom that could be MS, but they aren't sure, so it's called clinically isolated syndrome. 90 with relapsing remitting MS, 14 with primary progressive MS, and 23 with secondary progressive MS, who were followed for a median of 6.3 years as part of the Swiss MS cohort. Okay, I want to say a couple things there. That's not the hugest sample size you could possibly have, but I think for this kind of study, it's pretty good. And what I like about it is that there's a diversity of courses of MS here. You've got everything from CIS to primary progressive. All of the main subtypes are covered, so that's helpful. I'm also impressed that the study length is a median of 6.3 years. You hardly ever get studies that last that long, It adds a lot to the validity of the results when you go to such long time frames. And that might help us with the results to make some kind of at least tentative conclusions, as we are going to see. The study included as controls 31 people with an inflammatory neurological disease other than MS, and 44 people with symptoms such as migraine that aren't explained by clinical signs or other findings suggestive of a diagnosis. In the cerebrospinal fluid, or CSF, found in the tissue that surrounds the brain and spinal cord, but not the blood, the levels of complement proteins and their cleaved products increased with levels of albumin, one of the most abundant proteins in the blood. Levels of C4A, a cleaved product formed with the activation of the classical complement pathway, were 19% higher in people with CIS than with symptomatic controls. CIS is the first clinical presentation of neurological symptoms of MS. And 19%, that's pretty significant. In relapsing remitting MS, where relapses are followed by periods of recovery, C4A was increased by 41%. In primary progressive MS, where symptoms worsen gradually, the increase was by 53%. It was 58% in secondary progressive MS, a stage that follows relapsing remitting MS. Well, that's interesting, isn't it? That secondary progressive MS actually has a higher percentage of cleaved products than primary progressive even. I don't know if it's hugely significant. It's 5%. And in a larger sample size, maybe that wouldn't appear. But it's interesting to me anyway. It's kind of makes you wonder if there's a little bit of a difference in how secondary progressive is running beneath the surface. And we don't know that, of course. But this kind of research could help us learn what is going on. Measuring the levels of C3A and factor BA, other classical pathway cleaved products, revealed similar findings. The increases were most pronounced in those with high levels of IgG and IgM in the cerebrospinal fluid. So there's a nice correlation there. Say what you will, and whether you can say for sure what's causing it, the correlation is pretty significant and pretty easy to detect. Increases in EDSS and MSSS scores. In people with CIS, having double the levels of C3A and C4A in the CSF was linked to scoring about 0.3 points higher on the expanded disability status scale, where higher scores indicate greater disability. Twice the levels of C3A and BA in people with CIS or any other MS type was linked to an increase of up to about 0.7 points on the MS severity score, a tool that predicts future disability, where higher scores indicate faster disease progression. And I've never had one of those done, or at least I've never been told about it. I wonder, do any of you know anything much more about this? Have you had any experience with the MSSS score? I have, of course, the EDSS. I'm pretty familiar with that. But I'm starting to see this other one, and yet I don't think that anyone's ever talked about it in any of my neurological appointments. Let me know if that's not true for you. The levels of C3A, C4A, BA, and factor BB were also associated with up to 58% higher levels of neurofilament light chain, a small protein released into the bloodstream and other bodily fluids when nerve cells become damaged. The findings show higher levels of complement proteins, particularly their cleaved products, are linked to worse disability and more severe disease progression. They're also linked to nerve cell damage, suggesting complement activation may play a role in how MS develops and progresses. Complement inhibition should be explored as a therapeutic target, wrote the researchers, who noted that this might be a novel therapeutic approach to attenuate disease severity in MS and one of the highly needed tools to combat ongoing smoldering progression. Now, I'm keying in on that word smoldering because that's something that Dr. Giovannoni and others are saying, that, you know what, it doesn't do any good to reduce the number of relapses if MS is still smoldering beneath the surface. And so if this new insight helps us deal with smoldering MS, that would be a pretty cool thing. Well, as you can see here, this is fundamental research. This is not research that's going to immediately result in something that the doctor will be prescribing for us to help us with our current problems. But I do think that they're getting a little bit closer to the mechanisms that activate MS at certain points, depending on what's going on in the body. And what I really like is the very last line where the article talks about how this might actually be a way to target smoldering MS. Because I do agree with people who say that until we deal with smoldering MS, we will never be able to say that we've cured MS. We'll never be able to declare victory on it. This is a very slow, painstaking process, as I've tried to say in some of my other videos. This is not a disease that one morning we're going to wake up and read the headlines that it's been cured. And we can all just go to our doctor and get a shot or take a pill and be done with it. I think this is going to take quite some time. But that's okay, as long as what they finally come out with is safe and reliable and works for people. I'm willing to wait so that they'll do it right and that they understand why what they come out with actually works. Nothing more frustrating to me than to find that, oh, well, we have this technology, but we don't really understand it. I don't think that I want that. I don't want to put anything in my body that we don't understand why it's doing what it's doing. So that's it, though. I think that's exciting, and I'm looking forward to seeing how it might develop. If there's any more news on it, I will definitely be letting you know. But in the meantime, take really good care of yourself. Keep your general health as strong as it possibly can be, because we're in this for the long haul. I'll see you again in my next video.